All right, good day, everyone. So, we're going to be looking at this formula sheet that I've put together. And this is not the formula sheet that you're going to be getting in the exam. I just put it together so that you can just get a nice overall picture of the formulas or some of the formulas that you're going to be needing to solve these problems on internal combustion engines. And I'm just going to run through it very briefly so that you're familiar with it now. So, up top here, this is what we spoke about the last time I saw you guys, the power formulas. So you can calculate the fuel power by the mass of the fuel times the calorific value of the fuel. The indicated power, remember that's the power inside the cylinder, all right? So that explosion that's happening, how much power is happening inside of that cylinder. And then the brake power. So that's the actual power that's available to actually turn the crank. Okay, so normally that's the power that we are actually interested in. So if you buy a car, you're interested in the brake power because that's the power that can actually do work. All right, and then the friction power. So obviously, the power that is given off inside the cylinder is not the power that you're going to get out of the engine. That's what the brake power is. All right. So where's all that other power lost? From the indicated power, and that power is lost in friction. Because remember, inside of an engine, there's lots of different components that are rotating, moving up and down, and they're all interconnected with each other. Um, just like for example the connecting rods, the con rods, and those are there's bearings and there's oil, and all these things have friction, and that's where that power is lost. So to get the friction power, it's just the indicated power subtracting the brake power, and then you get the friction power. All right, and there I've got the formula for torque. You all know that in Newton meters. And then over here, there's a whole bunch of efficiencies, and this is nothing to be scared of, uh, but you just need to be aware of these different types of efficiencies. So they're just comparing, um, they are just comparing different powers and different efficiencies together. So I want you to just look through those and just be familiar with those. And many of those you're going to get on your formula sheet. And then we have, again, something else we dealt with is the specific fuel consumption formulas. It's those two. And then over here, very important little diagram, very simple one, but very important. So obviously at the top here, we have fuel power. All right. And that is the total power that you're putting into the engine. And now, if you subtract so obviously all of that fuel power is not going to be used to push the car forward or whatever it is, the boat or whatever. A lot of it's going to be lost. And we saw that also the last time that we met, that the efficiency of an internal combustion engine is actually really, really poor. And you can see that if you get out of a car that's been driving, you'll see that if you put your hand on the bonnet, you'll see that there's a lot of heat there. And if you had to touch the engine, if you opened up the bonnet catch and you lifted up the hood and you put your hand on the engine, you'd burn yourself. So a lot of the energy that is coming out of the fuel is actually being lost due to heat. And another place on the car is at the back of the car in the exhaust pipe. If you put your hand in the exhaust gases, you also burn your hand. So a lot of that power from the fuel is actually lost due to heat loss. So if we just look at this simple diagram now, we've got fuel power in. Right now, where are the losses that come out of that? So obviously, the radiator, which we call the cooler, so that is cooling down the engine. So certain of portion of this heat from the fuel goes into the radiator coolant, right? And that's hot water. Then certain heat from this fuel also goes out of the exhaust system. So the burnt up fuel, once it's burnt up, it goes out of the exhaust system, and there's a lot of heat energy in there. And then also what we call excess. So the engine block itself, that's like we said earlier, that's hot. All right. So those three places, heat is being lost, and we can't regain that. Then all the leftover heat energy is going to the cylinder. Okay, that's the indicated power. That's the energy that the cylinder is producing inside of it, and from that, like we said earlier, that is going then to the brake power, which we can actually use. And we know that the brake power plus the friction power equals the indicated power. So if you say the indicated power minus the friction, we got the actual power, the brake power that we can actually do something with. All right, so this diagram you need to know very well.